Alright, 11.4a is what I should have had here. Is about binomial distribution. First off, binomial distribution, BI meaning two options, means it is a distribution in which there's only two things that can happen: succeed or fail. The book discusses something where there are four parts and they want to make it into a binomial distribution, and your binomial trial might be that you actually have this as a success and everything else as a failure. So as long as it is a test or trial that has only two options or two results, then it's called a binomial distribution. But before we begin, there are functions that need to be identified for students who don't have scientific calculators at home. The Desmos calculator that I told you has access to what we call combinations and permutations. On the main screen, which is where you are here, that has this here, you have ABC, which allows you letters, and if you hit this function button, which is where I took the picture of what it does, you have all this stuff here. You have the NPR and the NCR, this is the button you're going to be using more today. You also see it has mean, standard deviation. I don't know what that is because I'm not that smart, but general idea again is that when you're using if you're using Desmos and you want to do the NPR, NCR, hit the function button. That will pull up these buttons here, actually even these over here, I guess, and it'll give you some other things that you can work with. Alright, so this lesson here contains two processes with some miscellaneous information going on. First, before we go, let's make sure we review the statistical variables, and I say review because you should have had statistics in Algebra 1. Some of this stuff should be kind of known, but N just represents the number of trials or the number of times you did something. The X, which is usually capitalized, is the number of successes. Alright, P, lowercase p, is the probability of success. It's using not a percent mode but a decimal mode. And Q, because P and Q usually work together, is the probability of failure. And the way you find Q, if you know what P is that you simply subtract 1. So if P was 30%, then Q would have to be 70%. Or if P was 0.3, then Q would have to be 0.7. If P was 0.18, then this would have to be 0.82. I think I did that right. But either way, take 1 minus whatever that is, and that would give you those. So those four variables you might want to write down if you don't know what they are, just as and not a long writing, but just a brief summary of what they mean. So let's introduce the new variable, which I believe is called mu. Again, I should have reviewed this, but it is the mean of a binomial distribution. It is found by multiplying n and p. And if you think about it logically, it's what we would expect. If someone is a 30% free throw shooter, that means they make 3 out of every 10, 6 out of every 20. Then it only makes sense that if we took the number of shots, if they shot 20 free throws, and multiplied by the percentage, which is 6, that 6 should be our number. Again, 30% is 30 out of 100, which is, I don't know, 15 out of 50, etc., etc. But either way, if you want to know what to expect, you take the number of trials times whatever the success number is, and that will give you what to expect. Now that number does come in handy, especially in the probability part, and that's why they use it in the probability itself. So the first process is a probability of X successes in N trials. It is it's not a formula, actually it is the formula, but it is the formula for a binomial case. And it is found by taking NCX, which is that button I just showed you. By the way, on these computers or calculators, you would use the PRB button, which is for probability, and choose NCR. Make sure I earn my money. On this calculator here, if you have one of these older ones, it's again PRB, and you use the arrow to go over to NCR. I think that actually has even more than that. It's interesting. But either way, you underline the NCR and then hit your button. And if you are one of the students who has a graphing calculator, the graphing calculator has it underneath the math menu. And again, you have to scroll over because there's your probability stuff over there. So you scroll over to probability, and then you would go down to NCR. You also have some other things there. I hope you remember what this means, the factorial button. But other than that, if you have a Casio calculator, I believe that you have to hit like shift and multiplication, because I think in those, before I go, sorry, because when I looked at it, they have the multiplication and the division symbol, and then they have like NPR and a different color, and NCR in a different color, and that color I think matches your shift button, so I think you have to hit like shift this, shift that if you want the NCR, NPR. But either way, let's break it down for some understanding here. NCX could be thought of as I want N trials or N tries, and I want this number to be successful. So if I am doing 15 tries, or let's do the free throws, I shot 20 free throws, I want 6 to be made. So 20 free throws make 6. Alright. P to the X makes sense because you're putting the successful probability, because remember that's the probability of successes, with the number of successes. So you take the decimal number of probability of success with the number of successes you want, and you also have to factor in the probability of failure and put that with N minus X, which N minus X is just the number of failed attempts. Think about it. If I am shooting 20 free throws and I want to make 6, then the failure number should be with 14, which is 20 minus 6. So if there's 6 here, then there should be 14 here. Whatever it is, whatever this power is and whatever that power is should equal your total number of trials, because N is the total number of trials minus your number of successes, which should give you the number of failures. But this formula is simply plugged into your calculator onto your computer, and it's found from there. So the majority of our work is going to be on this one question here. Talking about a telemarketing agency has found their particular staff has a 15% chance of making a sale on a call. What is the probability that the same staff can make 18 sales on the next 30 calls? So let's do this real quick following that process. First off, we want the NCR. So we have 30 tries, and we want 18 of them to be good. Again, 30 calls, I want 18 to work. I'm going to multiply that by the chance of success, which is 15%, to the number of successes, which is 18. And I'm going to multiply that by the chance of failure, which if 15% chance of success, there's an 85% chance of failure. If there are 18 successes out of 30, then there have to be 12 failures out of 30, and that is my number. And so I take my calculator and I plug that in. And so I do, for this, I usually do one thing at a time. I think if you're on Desmos, you can probably type it in, but I would be careful, and I would just use the calculator's memory to go. So I would do 30 C18 times, because notice I hit equals, parentheses, 0.15 to the 18th equals times 0.85 to the 12th, and I get a ridiculously low number, which makes me think that I did something wrong, because when I made this, and I was just telling my wife when I did it, I had to laugh because I got this answer and I thought, I think I really screwed up. But does this answer make sense? Let's think about this. This has a very, very small chance of happening, which is like 0.00002%. Does that make sense? Well, let's think about it. 30 calls, you want 18 to be successful. That's over 50%. The actual number for this staff is 15% success. So what's the chance of somebody, a staff that has 15% success, making 18 out of 30 calls work? It's very, very low, which is why you get this answer here. I guess class is almost over. But that's why this number here is what it is, because what would you expect to work would be where you do your number of calls times your percentage. And so we would expect 4.5 calls out of 30, which is why 18 is way above that range. I mean, they have to be on a hot streak to get that high on those numbers there. So let's use that now and kind of float around it and see what happens. What is the probability they make 7 sales on the next 30 calls? Again, same situation. Let's just analyze it a little bit. 7 successful calls, or 7 sales on the next 30 calls would be 30. Choose 7 times 0.15 to the 7th times 0.85 to the, if there's 7 good, then there has to be 23 bad. Again, that's the part you have to use on that, is whatever this number is, you got to use that, subtract it from this to find the other one. Now, I would not put 30 minus 23, but let's see. 30, choose 7 times 0.15 to the 7th times 0.85 to the 23rd. Gives me about a, I didn't write the answer up there, did I? But it gives me about a, if you move that twice, 8.3% chance of happening. And again, if we expect 4.5, the chance of getting 3 more, not as high. But again, I kind of want to walk you through this to make sure that we can kind of see where the expected variable makes sense. What about 2 cells? Because my thought is if they're able to make 4 calls, they should be able to make 2 cells. So let's see. So we would do 30, because we're making 30 calls, choose 2, times 0.15 to the second, because again we want 2 calls to work, times 0.85 to the 28th, because those 2 should add up to 30. So we go 30 C2, which is that number, times 0.15 to the second, I guess you can do that without it too, times 0.85 to the 28th is only a 10.3% chance. And why is that? Because the number that we would expect is 4.5. So let's look and see if 4 has a better chance on this situation. So we would do 30 C4. I promise this is the last one we're going to do, but you notice that we're still using the formula no matter what. 0.15 to the 4th, 0.85 to the 26th. Again, these two need to add up to 30. So I do 30, nope, not that button, 30 C4, I'm silly sometimes, 4 times 0.15 to the 4th times 0.85 to the 26th. And I want you to notice that that is a really high percentage chance. So based off of our percentages here, it should be 4.5. I'm assuming that if you wanted 5 calls, it'd be pretty close to that same percentage there. But notice that anything that's not 4 is not completely there. But again, even 4 calls or 4 cells is not like a 90% chance, because remember, all these percentages have to add up to 100. And so this can't take up 100% chance. It's not going to be 100%, but it is probably one of the majority numbers that's going to happen there. You should try 5 and see how that works. And then try 4.5 and see how that works, because that's probably a 25% chance or whatever. I don't know. I really don't know. Second process uses something called the binomial expansion to find the probability. First, let's look at the cog of binomial expansion, which is the, I think they call it the Pythagorean triangle. I have no clue what they call this, but I do know that you should have seen it before, and if not, welcome to a funny, useful math trick that we have. You start with a 1 at the top, you then surround that with 1s, and your next row you put a 1 on the outside, you add up these 2 numbers and end it with a 1. You then start with a 1 on the outside, add these 2 numbers, add these 2 numbers, end with a 1. You then start with a 1 on the outside, add these 2 numbers, add these 2 numbers, add these 2 numbers, and end with a 1. You then start with a 1, add the numbers, add the numbers, add the numbers, add the numbers, end with a 1. And you continue this process all the way through. Now, this part here can be used for different values of n. The first is n equals 0, and it's important that you know that, because that top row really isn't used at all, but it just starts everything. So this would be your n equals 1, or number of trials equals 1. This would be your number of trials equal 2, number of trials equals 3, number of trials equals 4, and so on and so forth. The key thing to remember whenever you do this is that n equals 0 is the first row, and you don't really start with the first row, and so you count your trials after that. But you would find out once I show you what we're going to do here to create the probability list. We are going to use the row of n equals 4, which is 1, 4, 6, 4, 1, to create a probability list. And what you do is you put 1, p, which is success, to the 4th, because that's the number, which means that q has to be 0, plus 4, p drops down 1, q goes up 1, plus 6, p drops down 1, q goes up 1, plus 4, p drops down 1, q increases 1, plus 1, p drops down 1, q increases 1. And this list pretty much shows you the chances of if there were 4 attempts or 4 things that you would be successful 4 times. This is a chance of, this represents the probability, and each one is separate, even though you could add them all up, but if you add them all up it should equal 1. But this one here would be just the chance of 4 successful attempts out of 4. This would be 3 out of 4. This would be 2 out of 4, 1 out of 4, and 0 out of 4. And that is used to help you to answer questions like this. Excuse me for a moment. So in this question it says, Terry has not studied for the upcoming multiple choice test, which sounds like Mr. Bradley when he was in one of his classes that he didn't like. If there are 5 questions with options A, B, C, and D, what's the expected number of correct answers? Well, again, what we would expect, if there are 5 questions with A, B, C, and D, we should have 5, which is your number, times your probability of success. If there are 4 of them, 1 out of 4 would be 25% chance, which is 1.25. So the lesson of the day right now is that if you have a 5-question assessment and it's multiple choice and you don't study at all and you know nothing at all about it, you are supposed to get around a 1.25. But let's create a binomial distribution for this situation here real fast. Again, there are 5 questions, so I will really quickly just go 1. That would be 1. That would be 2, 3, 4, 5. I guess you could kind of go off of the second number. That would be second, third, or that would be 1, 2, 3, 4, 5, or whatever. But this is the one we're going to use, which means that we want to do 1 p to the 5th q to the 0 plus 5 p to the 4th q to the 1st plus 10 p to the 3rd q to the 2nd, 10 p to the 2nd q to the 3rd, 5 p to the 1st q to the 4th, 1 p to the 0 q to the 5. Now, we typically have to fill this out, but again, what we're looking at is this is your binomial distribution, but we need to actually get the numbers. And so the way you get the numbers is you plug them in. So we really don't care about the 1, but we would end up with probability of success, which is 0.25 to the 5th, and again, q to the 0 we really don't care about, plus 5 times probability of success is 0.25 to the 4th, probability of failure is 0.75 to the 1st, plus 10, probability of success is 0.25, probability of failure is 0.75. This is going to take more than one line, but again, I just hope you understand where this is going. Plus 10, 0.25 to the 2nd, 0.75 to the 3rd, because I'm here now, plus 5, 0.25 to the 1st, 0.75 to the 4th, plus 1. Again, we don't care about the 1. We don't care about the P0. We care about the Q to the 5th. And so I'm going to type each one of these in. 0.25 to the 5th is 0.0009. I guess it's 0.001. Plus, I'm just going to type this in as it shows on the paper, 5 times 0.25 to the 4th times 0.75 to the 1st is and we're going to go 3 spots, so 0.015 plus, again the third one here, 10.25. I don't think I need to type that in all the way anymore, but 0.25 to the 3rd, 0.25 to the, 0.75 to the 2nd is what I'm looking at here. That gives me 0.088 I am going to use the recall function to pull this back down, because all I really need to do is change, based off of this, change this to a 3 and change this into a 2, which gives me 0.264 plus, I'm going to go back up to the one that had a 5, because I remember I typed that in there. I just got to turn this into a 4. Not a 14, that would be bad. And this into a 1, which gives me pretty much 0.40, plus the last one, which is 0.75 to the 5th, which is 0.23. I'm sorry, 0.237. So that is your binomial distribution of this situation. They are going to give you a question today where you are going to use these numbers here, but the key idea in those numbers is understanding what each one means. Remember that this is the probability of getting 5 correct. This is the probability of getting 4 correct, 3, 2, 1, and 0. And recognize the funny part, which is that there's a higher chance of getting 1 or 2 correct than there is of getting 0 correct. That's because getting 0 correct is about the same as getting all of them correct with a higher chance, because there's a 75% chance, but there's a higher chance that you get here or here in that situation. So if you were asked a question out of this without all this extra stuff, what's the probability Terry gets it 60% exactly? 60% to me is 3 out of 5, so 0, 1, 2, 3. There is a 8.9% chance that Terry gets a 60% on the dot. So again, when you do this on the computer today, this is going to be set up in boxes. Just be careful not to put this answer here, because that's what I did on accident, is I put that there because it has 0, 1, 2, 3, 4, 5. That's 5 correct. Remember that it should go on the bottom. Other than that, go ahead and enjoy the rest of your day, and I think you only have a few questions to work on today. I think. Good luck.